Hello everyone, welcome to my channel. Let's solve this question together. Now look at what you are given. We are given that x to the power of what x divided by x plus 7 equals to what 13. We are expected to find the value of x. Questions like this are very simple if you obey the properties of what lambda, indices and what logarithm, right? Now our first thing what you're going to do is to clear the denominator from here, which is x plus 7. And for us to do that, we have to multiply both powers by what? By x plus 7. So we're going to add this is what? X to the power of what? X divided by x plus 7, right? Then multiply by x plus what? 7 equals what? 13 to the power of what? X plus 7, right? Now we have multiplied both powers by x plus 7 so that this can go out because that's our target, right? So now that is x to the power of x equals to. Now if we obey the properties of the multiplication law of indices, we can split this as 13 to the power of x multiplied by 13 to the power of what? 7. Because if the bases are the same, we can take a single base and add the exponent and we'll have exactly what is here. Wow, this is fantastic, right? Pocket unions, right? Now what are we going to do is to divide both sides by x to the power of x. So I remove x from here. So if we divide here by x to the power of x and divide the whole of this by x to the power of x. X to the power of x divided by x to the power of x, we just have 1 equals to. Now do you know that there's another amazing thing we can do if we obey the properties of indices? We can do something very interesting as 13 to the power of what x, then multiply by 13 to the power of 7, then multiply by x to the power of what minus x. Wow, this is fantastic, right? Now let's remove 13 to the power of 7 so that x can stay alone. So if we divide here by 13 to the power of 7, we are dividing both sides. Don't forget, divide here by 13 to the power of what 7. So that this cancel out this. We are left that 1 divided by 13 to the power of what 7. Okay, is equals to 13 to the power of what x multiplied by x to the power of minus what x. Wow, this is amazing. Wow, this is pocket unions and I love this. Now at this point, what are we going to do? I can write this as 13 to the power of what minus 7 if I obey the properties of indices very well. You know that a raised to the power of minus m is equals to 1 divided by a raised to the power of m. Get it? That's beautiful, right? At this point, I can write this as this is equals to 13 to the power of x divided by x to the power of x because of this x to the power minus s. Sorry, it will now become 1 divided by x to the power of x, and 1 times this will be same as this, right? Now at this point, we now have that 13 to the power of minus what minus 7 is equals to into 13 divided by x all to the power of x, because it means that the power here you're seeing is affecting the 13, also affecting the x. So it means you're having s here, s here. Why are we doing so? Because there's one of the properties of indices that say that a raised to the power of m divided by b to the power of n is equals to into a divided by b all to the power of what? N. Have you seen that? Before I start this video, I said that we're going to obey 3 properties: logarithm, indices, and what the application of lambda w what function. That is the 3 applications that govern this question, as you can see here. So if you don't understand those principles, you find the question challenges to solve. At this point, let's stop here and we'll do something interesting. That let the 13 over s be equals to any variable of our choice. Let it be what? Let it be c. If it's c, you can call this equation 1. Let's make s the subject. It means that xc is equals to what? 13. So if we divide here by c and divide here by c cancel out, so x is equals to 13 divided by c. I can call this equation 2. It implies that if I can know the value of c, I've gotten the value of x. Can you see how simple and interesting it is? Very simple and interesting. So let's substitute all this into this. We have that 13 to the power of minus 7 is equals to, we have 13 over x as c. So I have this as c to the power of what? Look at x is what? X is 13 divided by what? C, as you can see here. Now, our target here is to remove 13 from here. So what you have to do is to multiply both power by the reciprocal of 13. Take note that the reciprocal of 2 is equals to 1 over 2. So the reciprocal of 13 will be equals to 1 over what? 13. So we want to multiply both powers by the reciprocal of 13. So what that this is into 13 to the power of minus 7 multiplied by the reciprocal, which is 1 over 13, equals to what? Into c to the power of what? 13 divided by c multiplied by 1 over what? 13. So that this cancel out this, and we are left with what? We are left with 13 to the power of minus 7 over what 13 equals to c to the power minus 1 over what c. Wow, this is amazing. At this point, we can say let 1 over c equals to what d. So you can call this equation 3 because it's a new equation we are getting. So let's make the c the subject. It means that 1 is equals to cd. So if you divide here by c and divide here by c, sorry, we're making what the subject? We're making c the subject, right? C. So divide both sides by d. Divide here by d, divide here by d. D cancel out. So this implies that c is equals to 1 over what? D. You can call this equation 4. That implies that if you can know the value of c, if you can know the value of d, you can know the value of c. If you can know the value of c, you can know the value of what? X. Wow, this is fantastic, right? And you love it, right? Beautiful. Now let's go back. Let's put it back. So that this is 13 to the power of what? Minus 7 over 13 is equals to, we having c here. What is our c? Our c is 1 over d. So this is into 1 divided by d, all to the power of what? The power here is 1 over c. And 1 over c is what? 1 over c is d. So this is what? D. Wow. And if we know that 1 over d can also be seen as d to the power minus 1. So that means 13 to the power minus 7 over 3 is equals to into d to the power minus 1 all to the power of d. And take note that by one of the properties of indices, that the index inside the parentheses can multiply the index outside the what? Parentheses. But wait, let me check my mic, please. Sorry. Alright. Now remember that the index inside the parentheses can multiply the index outside the what? Parentheses. So that this is what? 13 to the power minus 7 over what? 3 is equals to d to the power minus d. So, and I want to remove minus 1 from this d. So, I will multiply both powers by minus 1. So, if I do that, everything will clear off as 13 to the power of 7 over what? 3 is equals to d to the power of d. And at this point, what I'm going to do is to apply the natural logarithm on both sides as ln what? Ln 13 to the power of what? 7 divided by what? 3 equals to ln d to the power of what? D. And note that this can go back as what? 7 over 3 ln what? Ln 13 then equals to d ln what? Ln d. And if you go deep down to some of the properties of logarithm, we have some laws that we have to use to apply this particular question. I want you to note that the e raised to the power what? Ln a is always equals to what? A. So from here, I can write this as what? 7 divided by 3 ln what? Ln 13. Okay. Ln 13. Is it 3 or 13? Sorry. This is 13. Sorry, it's 13. You can see it's 13, not 3. It's 13. No, sorry. It's 13. Alright, thank you for that. I love that. I just check it very well. You have to be very careful when you're solving question. So that means with what? Equals to, I can write this d that you're seeing as e raised to the power ln d. It's nothing bad because there's something I want to do. That's why I'm using that. Right? And if we go to the properties of lambda, that lambda the function into a, the e multiplied by e to a is equals to a. So another properties of lambda. That means 7 divided by 13 ln what? Ln 13, right? Is equals to the lambda the real function of what? So let me take a lambda here. That means lambda the real function of into 7 divided by 13 ln what? Ln 13 is equals to the lambda the real function of into e to the power ln what? Ln d multiplied by ln what? Ln d. So that means the lambda the real function of what? Into 7 divided by 13 ln what? Ln 13 is equals to ln d. If you obey these properties of lambda here, that the real function of a multiplied by e to a is equals to a. So it means that the real function of e to e raised to power ln d multiplied by ln d will just give us ln d. And if you raise this as e raised to power the real function of what? Into 7 divided by 13 ln what? Ln 13 is equals to e raised to power what? Ln what? Ln d. There's nothing changed, my brothers and sisters, because since the bases are the same, I can equate the powers and I'll have exactly what is here. Now, from these properties here will just be d. So this implies that our d is equals to e raised to power the real function of what? Into 7 divided by 13 ln what? Ln 13. Now we're getting the value of d. But remember, we are not asked to solve for d, neither c. We are expected to find the value of x. But why are we doing this? We are doing this so that this question can be very easy and smart to solve, okay, and very simple to approach, right? Now let's go here. We know that our equation 2 is s equals to this, where this. So let's go and find c. So for us to find c is from equation 4, we'll find c. You're able to use equation 4 and equation 2. Equation 2 is x equals to 13 divided by c, which is equation 2. So I can remove everything here, okay? I'll use equation 2 and solve for this. Alright, we're gotten d, right? So let's go and find what? Let's find c. We know that from equation 4 that c equals to 1 divided by d, which is equation 4. So it means our c is equals to 1 divided by our d, which is what? E to the power of the real function of what? Into 7 divided by 13, right? 7 divided by 13 link what? Link 13. Now I've gotten the value of c. Now, and we know from equation 2 that our x is equals to 13 divided by c, which is equation 2. So it means our x will be equals to 13 divided by 1 over what? 1 over e to the power of the real function of what? 7 over 13 link what? Link 13. Right? Now this is s, but I can simplify it further as s equals to bracket 13, division sign is here, 1 over what? E raised to power 13, e raised to power is the real function of what? 7 over 13 link what? Link 13. And from here, I've gotten the value of what? Of x.